The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. When you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@yvcc.edu and I will respond as soon as I can. So hopefully you all took your test. I will be correcting that today. And then if you have any questions that you want me to go over with you, email me and I'll be happy to contact you, but I'm not going to go over test questions during the class Zoom meeting. So today we're going to start chapter 2 and we're going to be spending a couple days on that. So today is part 1. And what we're going to be doing today is talking about functions. How many of you have had some exposure to functions before?
I have, but I forgot.
Okay, and that's kind of the typical answer. Yeah, I sort of remember it, but I forgot it. So let's review the idea. And I'm going to start out with reading a definition out of the book. And let's see if I can find it here. It says, a function is a set of ordered pairs in which to each first component, there corresponds exactly one second component. The set of first components is called the domain of the function, and the set of second components is called the range of the function. All right. So a function is a relation where the following thing happens. For each value of input, there is exactly one value of output. And what I want to use for an illustration is I want to talk about people and their birthdays. Let's say we have a group of people, Sam, Jose, Ben, Maria, and Lois. Okay? And over here we have birthdays. June 4th, that's Sam's birthday. April 8th is Jose's birthday. October 3rd is Ben's birthday. Also happens to be Lois's birthday, and Maria's birthday is March 20th. Okay, so notice that everybody has a birthday. Okay. No one has more than one birthday, discounting religious experiences, of course. So each person has just one birthday, but also notice that Ben and Lois share the same birthday, but that's okay. You can have two different people with the same birthday. They might be twins. They might not even know each other, but each person has exactly one birthday. More than one person can have the same birthday. Well, let's read what it said about a function again. It says, a function is a set of ordered pairs in which to each first component, there corresponds exactly one second component. Each first component corresponds to exactly one second component. You can have Ben going to October 3rd, Lois going to October 3rd. So two people can share the same birthday. That still works how a function works. Okay, but you can't have one input with two outputs. Sam couldn't have a birthday on June 4th and on April 8th. Okay, does that make sense?
Yes.
Maybe? All right. I also want to point out that function starts with the word fun, but it also ends with the word shun, and we know what shun means. So anyway, but let's hope that we can focus on the fun part. All right. I want to look at some different names for things. Input, output, x coordinate, let's see, didn't spell that right, coordinate, I can abbreviate, y coordinate, domain, range, independent variable. Is independent ANT or ENT? think it's ENT.
ENT.
Okay, dependent variable. And then cause, effect. So those are different ways of describing the same situation. The input or the X coordinate or the independent variable or the cause we call the domain. The output or the Y coordinate or the dependent variable or the effect we call the range. I want to talk first of all about cause and effect. You don't see that mentioned much in books, but to me it kind of helps you get a picture of what's going on. So have any of you been outside today yet?
Yes.
Was it cold?
Cold and sunny.
Cold and sunny. Did you put on a sweater or a jacket or something?
Yes, a jacket.
Okay, so did you put on a jacket because it was cold, or was it cold because you put on a jacket?
I put on a jacket because it was cold.
Right. So who was in control, your jacket or the weather? The weather. The weather was the cause. The effect was you put on warm clothing, not the other way around, right?
Yes.
So the weather would be the input. What you wore would be the output or the result of it. And that may come in handy later on when we're trying to figure out, well, which thing is the domain and which thing is the range. In general, domain, we're talking about X. And the range, we're talking about Y. It can take on other variables, but when we're just dealing with X and Y like we do most of the time, basically the domain is all the X values, the range is all the Y values. Okay, now, let's say I've got, let's say, yes, I've got the following ordered pairs. Let's see, 7, -1. One of these days, my voice will stop cracking. Probably not, though. I just hope. Let's see, -5, 3, and 8, -6. All right, it says find the domain and range of each relation. It's as simple as this. The domain is all the X values. The range is all the Y values. Now, notice I'm listing them from smallest to largest, which is what we typically do. Also notice that I'm very bad at making braces. Oh, well. You okay with that?
Yes.
All right. Now, let me ask you this. Does this appear to be a function?
Yes.
Okay. Let's see here. Does this appear to be a function?
Would it be yes? Because so the two ones that are in the middle are both -3 as far as the X. So the domain, but the output is a different number.
So
Or would
is
it be
that
the
a,
other way around?
so does that describe a function?
I believe so. Or is it the other way around?
Yes.
The way around? Okay.
We've got the same person with 2 different birthdays. We've got an input with 2 different outputs. So not a function. Okay?
All right, got it.
Yeah. If it was the other way around, like 8 goes to -3 and 12 goes to -3, that would be okay. But here we've got the same input going to 2 different outputs. It's still a relation, it's still graphable, but it's not a function. Okay? Okay. This is called a mapping. The domain's on the left and the range is on the right. Function or not?
Yes.
Yes.
Good.
Function.
Yes. Function or not?
Yes.
No.
Wait, no, I didn't see that.
Why not? Give me the evidence that it's not a function. Why not?
Because the 0 has the range of 10 and 12.
Right. So there's two ordered pairs that show it's not a function because the same input has two different outputs. So not. Okay. Function or not?
Yes.
Yes. Triplets. 3 people with the same birthday. Function. Oops, let's make those circles a little bit bigger. Function or not?
Would it be no?
Correct. Here we have a person, we should be studying this in psychology. Here's a person with 3 different personalities or something. No. But this, not a function. You've got one input going to 3 different outputs, so not a function. Okay. Each input can only go to exactly one output. You can have several inputs going to the same output, but you can't have one input going to several outputs. All right. Yeah. Function or not?
Yes.
I didn't see that.
Neither did I.
I know it's my sloppy writing. So here is evidence that it's not a function. So you got to look everything over. Okay, now, oh, here's one more. Function or not?
Would it be yes?
Yes, quadruplets. I think that's right. 4 different inputs with the same output, 4 people with the same birthday. Okay. Now, let's take the equation y equals 2x plus 3. And let's make a table. How about -2, -1, 0, 1, and 2? And let's complete the table. So if x is -2, how do we determine what y is?
You just plug in -2 where x is
Okay.
and solve.
All right. Same thing here, right?
Yes.
And finally, You get that, right? Okay, now. Let's get rid of all this because we're going to need some room here. Okay, come on here. Does this look like it's a function?
Yes.
Yeah, and in fact it is. Because this equation is a function, there is a special way that we can write this equation that tells everybody reading it that, oh, it's a function. We use a symbol instead of y. And we're going to start off with this symbol. Now, that's sort of an italicized F, okay? This is a single symbol. It looks like multiplication because you've got parentheses around the x. So F parentheses x, you would think, oh, that's F times x because it looks like it, right? But it's not. The long way of saying this is F is a function of x. The shortcut way of saying it is F of x. Well, if you think back to a previous math class when you studied percents, if you had 3% of 4, that was 3% times 4. So of can also mean multiplication, but here F of x does not mean multiplication. So it looks like F times x, it sounds like F times x, but it's not. It's just a single symbol that's another name for y. So instead of saying y equals 2x plus 3, we could say F of x equals 2x plus 3. What that tells the reader is that, oh, that's a function. That equation behaves according to the pattern that for each input, there is exactly one output. Now, we're going to find some ordered pairs, so to speak, using function notation. Let's say I want to find F of -2. -2 went in the place of x. -2 is the input. To find the output, to find the y value, I do the same thing I did on the left side of the screen. I'm going to put -2 in for x. So F of -2 equals, can't see the negative over here, -1. Okay, so this is the same piece of information as this is the same piece of information as that as an ordered pair. So here's a table, here's an ordered pair, here's a relationship using function notation. F of -2 equals -1. The input is on the inside, the output is on the outside. The x value goes in here, the y value comes out the other end. Okay? What would F of 0 equal? Well, that would be 2 times 0 plus 3, which is 3. So F of 0 equals 3. What would F of 2 equal?
Two parentheses 2 plus 3.
Which is?
2 times 2 is 4, plus 3 is 7.
What? Nobody cheated and just looked over there?
I got nervous. I just did it.
Either way is right. In other words, F of -2 is going to be -1. F of -1 is, because we're doing the same thing. It's just a different notation, different set of symbols for accomplishing the same thing. Inputs and outputs. These would be the domain values. These would be the range values. The inputs are the domain values. The outputs are the range values. Okay? All right. Now, suppose we have the function F of x equals 3x minus 5. And we want to find specifically F of 3 and F of -1. So what we're going to do is the same thing we did before. The 3 is on the inside. It represents the x value. So we'll put that right up there and we'll get 3 times 3 minus 5, which is 9 minus 5, which is 4. So f of 3 equals 4. That corresponds to the ordered pair 3, 4. That corresponds to a point on the graph with the coordinates of 3, 4. This is a function in slope-intercept form. Y equals mx plus b. It's just that we're writing y using function notation. F of -1 would be 3 times -1 minus 5, or -3 minus 5, or -8. So f of -1 equals -8. That corresponds to the ordered pair -1, -8, etc., etc. Okay, so we're not really doing anything new here. We're writing different symbols for the same thing, but it's still the same process. We've got an input and an output, an X and a Y. How are we doing?
Good.
Okay. If anybody starts freaking out, let me know. G of X equals 5x squared plus 2x plus 2. Find G of 2 and G of 3. So what are we going to do to find G of 2?
Is that the same as saying f of x still?
Oh, I switched variables on you, didn't I? Good question. Yes, it is. So just like in graphing ordered pairs, we tend to use X and Y. That's sort of the main one. We can use others. We tend to use f of x, but we can also use different letters for it. In fact, if we were in Math 111, a business algebra class, and we were talking about a cost function, it would be C of x. A revenue function would be R of x. A profit function would be P of x. So G of x is really no different from f of x in that it's just another function where you know, it might stand for something to do with that starts with a G, but yeah, they're just exposing you to other variables, but good for you. So we're going to treat it, we're going to find the result the same way we would do other things. So what does that mean? What are we going to do? How are we going to find G of 2?
We'll plug in 2 for the x's in the equation.
Exactly. So we could say G of 2 equals 26. If we were to graph this function, and later on this quarter we will be, the point 2 comma 26 would be a point on the graph. Okay, how would you find G of 3? The same way. 5 times 3 squared plus 2 times 3 plus 2. 5 times 9 plus 6 plus 2. 45 plus 6 plus 2, which is 53. So G of 3 equals 53. Okay with that?
Yes.
All righty. Let's see. How about this? H of x equals the absolute value of x minus 5. And we're supposed to find H of 5 and H of -2. So how would you go about finding H of 5?
Plug in 5 for the x.
Bingo. What's the absolute value of 5? Do you remember how that works?
Wouldn't it just be 5?
Yep. And what's 5 minus 5?
0.
So H of 5 equals 0. 5 comma 0, that would be what? An x-intercept on the graph of H of x equals the absolute value of x minus 5. How would you find H of -2?
The same way, plugging in -2.
What's the absolute value of -2?
-2.
Ah,
+2.
+2. 2 minus 5 is -3. So h of -2 equals -3. Remember, absolute value is always positive, except the absolute value of 0 is 0. So absolute value is like a distance on the number line.
Okay, so it doesn't matter what number is in there, it's always going to be positive.
Yeah, unless it's 0, and then it's going to be 0.
Okay.
Mhm. Okay. How about this one? Oops. Oh, that's clever. Hit the wrong color. Oh, well. Now it looks like your homework assignments, huh? Parts of it are in red. Okay. We want to find h of 5 and then h of -2. So how would you go about finding h of 5?
You plug in 5 where all the x's are.
Yep. So 5 squared plus 2 times 5 minus 35 over 5 squared plus 5 times 5 plus 6. 5 squared is 25 plus 2 times 5 is 10 minus 35 over 25 plus 25 plus 6, which is 0 over 56, which is what? What's 0 divided by 56?
I always get confused. It's either 0 or undefined.
0, because if it's 0's on the bottom, it's undefined.
Good for you. Yes. Okay, so that's 0. Now let's do this other one here. -2 squared plus 2 times -2 minus 35 over -2 squared plus 5 times -2 plus 6, which is 4 minus 4 minus 35 over 4 minus 10 plus 6, which is -35 over 0, which is what?
Undefined.
Right. So 0 divided by a non-zero number equals 0. A non-zero number divided by 0 is undefined. It's all fun and games till you divide by 0, and then it's undefined. Okay, now
So
go ahead.
you did mention that all the other ones like eventually will graph. So when it's undefined, we don't graph. Or
That's true. That's true.
okay.
So if we were graphing this picture, or if we were graphing this equation, excuse me, at x equals -2, there would be no graph. And we'll explore that more later. But what I wanted to say right now is this. -2 is not in the domain of this function, because when we put -2 into the function, it did not produce a real range value. Okay.
So how would we find the real range value?
By finding the values that don't work and throw them out.
So like for h of 5, it was 0, right?
Yes. 0 is
So
real.
yeah, so 5, 0, right?
Would be a ordered pair, point on the
That would be
graph
the coordinate.
solution.
Okay. So that'd be the coordinate. So that one we can graph, but if it's undefined, we can't graph.
Correct.
Okay.
So back to this, -2 is not in the domain of this function. When I was a small child, I lived out north of Selah in the Weenass Valley. And I recall that my mother had a meat grinder that was made out of pot metal. And pot metal is kind of a cheap metal that's just not super strong. Okay. And so she would take roast beef and put it into this meat grinder, grind it up, and it came out, kind of looked like worms coming out, but it tasted really good. And you put it on sandwiches and stuff. But anyway, my brother took a rock and stuck it in the meat grinder. What happened?
It either broke or it didn't grind.
But what would most likely happen if you put a rock in there and turned the crank?
It would flick out, try to come out.
Oh, you're overthinking this. Wouldn't it break the meat grinder?
Yeah, it
Because
broke.
it's cheap. My point is this. You don't put a rock in a meat grinder. You put meat in a meat grinder. And by the way, that story's not true. So if you run into my brother, don't tell him I'm saying bad things about him here. Anyway, but we did have a meat grinder. And the point is, you put meat into a meat grinder because then you get good results. -2 is like the rock in the meat grinder. It didn't give us good results. It came out undefined. So -2 is not something you'd want to put into this function. We say -2 is not in the domain of the function. Okay. Now, let's take a look at this problem. G of x equals -3x. We are supposed to find G of W and G of W plus 1. Don't overthink this. For G of W, what's the input?
W.
So what are you going to do?
Put W where the X is. So,
So what would you get?
-3 times W.
Yep, that's it. Oh, all we did was replace X with W. Yep, that's it. Now, again, don't overthink this. G of W plus 1. What are you going to do with the W plus 1?
Put it where the X is.
So you'd get -3 times W plus 1. But we're not done yet. We're going to distribute and get -3W, minus 3. Okay?
Yes, got it.
All right. What's G of star?
-3 times star.
What's G of Barbie?
-3 Barbie.
Okay. Oh, let's give equal opportunity. What's G of Ken?
-3 Ken.
Right. Again, don't overthink it. In fact, in general, you could say G of this equals -3 times this. Whatever you put into this goes in the place of this. Okay.
Okay.
Don't make it more than it is. All right, now. We've been putting inputs in and getting outputs out, putting X's in and getting Y's out. Let's say we let f of X equal -2x plus 5. For what value of X, does f of X equal -7? Now, f of X is another name for,
Y.
so in this situation, what is Y equal to?
-7.
So instead of putting in an X and finding Y, now they're telling us what Y is, and we're going to find X. So where would we put the -7?
On the other side of the equation where f of x is?
So am I going to write f of -7?
Yes.
Would
No,
you
because
just
that's where the x is.
seven?
It's
just
going to
have
replace the whole
-7.
thing. If I wrote f of -7, that would mean that -7 was the input.
Yeah.
Okay, I tricked you. Sorry, that was mean of me. I could say I'll never do it again, but that might be a lie. So you see what's going on there?
Yeah.
It's basically like we're saying, oh, we're going to complete this ordered pair. We know what y is. We don't know what x is. So you put the y value in place of y. Remember, all of that is y. So now how am I going to find x?
You solve.
Yeah, solve it. So we'll subtract 5. Divide by -2. So x equals 6. So for what value of x does f of x equal -7? For x equals 6. Okay. We just want the domain. Hang on. There we go. Okay. The function h of x equals 3x plus 6. We want to know the domain. So rather than finding the domain, let's figure out what's not in the domain. What values of x, if we plugged into this function, would not give us a real number as an output? The only thing we've really talked about is dividing by 0 is undefined. Is there any way that we could put a number in for x that we then would have something that was divided by 0 in this case?
0.
That would give you 3 times 0 plus 6, which is 6. The 0 would have to be in the denominator. There is no denominator here. It's just an implied 1, and so you can't replace it. So the domain would be all real numbers. Or if you wrote that in interval notation, it would look like that. Let me give you another example, and maybe that'll clarify this one. F of x equals 1 over x minus 4. What's the domain here? Or better yet, what's not the domain?
1.
What?
Oh wait, sorry. I thought you said denominator.
What's not in the domain?
The f of x. Right?
Let me put it a different way. Is there a value of x that if I plugged it in, it would make the denominator 0?
4.
There you go. So the domain is x does not equal 4, because f of 4 would be 1 over 4 minus 4, which is 1 over 0, which is undefined. See that? So the question is, when will that be 0? Well, if x is 4, you'd have 4 minus 4 is 0. 1 divided by 0 is undefined, right? So the domain x can't be 4.
So like if you have an equation and you're just trying to find out how it equals to 0, and if it doesn't, it's all real numbers?
When the denominator is equal to
When
0.
the denominator, okay.
Right. There's more to it than that, but that's all we're exploring at this point. We're just going to look at dividing by 0. Later on, we get to chapter 9, we'll talk about taking even roots of negative numbers, and that's another problem, but we'll deal with that later. So for now, we want to avoid having the denominator 0. Now, this is a way of saying the domain x is not equal to 4. You could write it out and say all real numbers except 4. Or in interval notation, it would look like this. Everything from negative infinity up to 4, but parentheses around 4 showing you don't include it. Union symbol, everything after 4 to infinity. So this is everything except 4. I think WebAssign tends to do this. If we were in the normal classroom, I'd have you do this. And I think later on, they may actually ask you to do the interval notation as well. So and again, that was first learned back in section 2.7. If you need review on that from me, office hour, come see me. Happy to spend all kinds of time with it. Let's look at another one. Let's see here. G of x equals the absolute value of x minus 7. Okay. Again, don't think what is the domain, think what is not in the domain. Is there any real number that if you put it in the place of x, subtracted 7, and took the absolute value, you would get undefined?
So I have a question. Since you said the absolute value, all numbers are always going to be positive.
Or 0.
Or 0, yeah. Do we have to change that negative to a positive sign?
No, because what you do, let's do this. Let's find g of 3. Okay, so that would be 3 minus 7, which is negative 4, and then you take the absolute value of negative 4. So you wouldn't change that sign. We'd put in a value for x, simplify inside, and then deal with the final simplification.
Okay.
All
So to answer your question, it would be 7, right?
But what is g of 7? That's the absolute value of 7 minus 7, which is 0. All right.
Oh, but it can be 0, like you said.
0's okay. You can't divide by 0. This has no denominator. There's no variable in a denominator, so there's no way you're going to be dividing by 0.
Right.
So I should have said, so the domain would be all real numbers. Long before that was a hashtag, it meant numbers. Okay, now, how about this one? Okay, h of x equals 9 divided by 2x plus 1. What's the domain? So the question is, what's not the domain? When will 2x plus 1 equal 0? Well, let's take the denominator and set it equal to 0 and solve it. Oh, that's the bad guy. So the domain would be all real numbers except negative 1/2, or interval notation, negative infinity up to, but not including a negative 1/2, after negative 1/2 up to positive infinity. This value of x makes the denominator 0, makes the whole thing undefined. Therefore, it's not a good choice to put in. You're putting a rock in the meat grinder.
I have
Okay.
a question. I know this is from another chapter. I don't remember, but I know the union, there's one up and one down. What is the difference?
Union, intersection. In fact, when we get to section 8.4, no, trying to think of what it was. Yeah. Yeah, 8.4. We'll talk about that more extensively, but basically intersection is what they have in common. Union is taking all of both.
Okay, so just use the union one.
Yeah, in terms of what we're doing right now. But yeah, in
Okay.
fact, today, it's interesting. The Math 93 class is also in chapter 8. they're slightly ahead of you in chapter 8 just because they didn't do as much to get here as you did. So, but anyway, yeah, we'll be talking more extensively about that. But this means union, this means intersection. This means you take it all. This means you only take the part that the two sets have in common.
All
So
right.
here we're saying all of this along with all of that, basically everything except that. Okay. Let's see here. One more. H of x equals x cubed. What's the domain?
There would be none since there's no denominator, right?
There would be no restrictions. So then the domain would be,
Would it be all real numbers then?
yes. Yes. So I've been focusing on finding the bad guys and booting them out. Okay. This has no restrictions, so the domain would be all real numbers, or from negative infinity to positive. Okay. Now let's say I had this. Let's say I had g of x equals x cubed over x minus 1. Well, now x couldn't equal 1, because if it did, you'd be dividing by 0. But here, the implied denominator is just a positive 1. There's no way you can replace the number 1 with a 0. Okay, whereas here, because there's a variable in the denominator, there is a value of x we can put in there that makes the whole thing 0. That is the whole denominator. Okay, so you don't want to divide by 0. You can have 0 in the numerator, you just don't want to have 0 in the entire denominator. All righty.
Alrighty.
Yes, got it.
Okay, I'm going to stop the recording.